Hey students, today I am going to tell you something about lens maker formula. So what is lens maker formula? Lens maker formula is 1 upon f is equal to 1 upon v minus 1 upon u. This is lens maker formula. What is the use of this formula? Where is used this formula? This formula is used to find out the position of image formed by lens. This formula is used to find the position of image formed by lens. So we all know that the image formed by lens is different when object is at different places. There are two types of lens. Both lens we know that convex lens and concave lens. Both form different image at different position. But how to apply this lens maker formula? How to apply this lens maker formula? Before going that, we know some terms. F stands for focal length. V stands for image distance, and U stands for object distance. Initially, I have an object, so that's why U is used as initial velocity, but there is no velocity. U is initial object. That means first of all we take object, then their image is formed. So this is the trick, not the term. That means हम ऑब्जेक्ट को पहले रखते हैं, इसीलिए यू इनिशियल होता है. हम लोग पहले जानते थे वेलोसिटी में. उसी प्रकार से ऑब्जेक्ट डिस्टेंस, दैट मीन्स आप गड़बड़ ना हो, ये ट्रिक है. यू इज ऑब्जेक्ट डिस्टेंस, वी इज फाइनल वेलोसिटी होती थी, मतलब बाद में बनेगी क्या, इमेज. तो फाइनल क्या, इमेज डिस्टेंस. दिस इज ट्रिक ओनली. नाउ देयर आर 4 rules by which we can use this formula to find focal length, find image distance, find object distance. But how can we apply this formula? There is sign convention rules. There are 4 types of rules. First one is that you must remember these rules, then you can easily solve problems related to the lens. First one is that focal length of convex lens is always positive. I repeat this term twice, by diagrammatic and by words, by sentence. Focal length of concave is taken as negative, and you have to learn these 4 rules by which you can solve the problems related to lens maker formula. What is lens maker formula? 1 upon f is equal to 1 upon v minus 1 upon u, not positive. If the positive is there over, then this is mirror formula ho jayegi. Okay. Second term is that all distance measured from distance measured from O. What is O? Optical center. We have already told about the optical center in lens, but I repeat again that optical center, what is with diagrammatic view. So this is important. From where? Optical distance. All distance measured from optical distance I am going to discuss with diagram. First, I give the 4 types of sign convention rules by which you can make or you can find focal length, image distance, or object distance. Third is distance measured in direction of where incident ray travel, in the direction of incident ray travel. Third is distance measured Direction of incident. Direction of incident ray. Distance, whatever distance we measure is distance, direction of incident ray, such as this is image, this is object, and incident ray going like this, then this direction is taken as positive and opposite to this direction is taken as negative. We will discuss in the form of Cartesian form with diagram. There is no fixed, either the left or right, there is no fixed direction by which we can take negative or positive, but the distance measured direction of incident ray is taken as positive and opposite to the direction of incident ray is taken as negative. This is incident ray taken as positive, but if we measure distance from O, distance measured from O in the direction of opposite to the incident ray taken as negative. And the last rule you already know is that height above fourth is what? Height above the principal axis is as positive, and below principal axis is taken as negative. That means if we suppose this is principal axis of this lens, then this direction is taken as negative, this direction is taken as positive. This is optical center O, all distance measured from O. So direction, if we suppose this is the incident ray direction, then this is taken as positive, all distance measured from O. So what if direction is measured in this direction, this is taken as negative because it is opposite to incident ray. So we are going to discuss with diagram. So I rub the board. You must have to remember these 4 rules by which you can make easy. So what is the use of lens maker formula, dear? Used to calculate position of image of which? Of lens. So I make just this is principal axis. You all know Cartesian form in math, standard 9th. This is principal axis. Suppose I make a lens that is convex lens, like that. We are going to use, this is optical center O, all distance measured from O. I make the same lens there. This is concave lens, black one is concave, blue one is convex. This is what? Principal axis. Suppose we take incident ray of light going like there, going like this. Suppose we take that incident ray of light going from left. So the direction of incident ray is taken as this direction. I read S.C. Verma, there is taken generally direction of incident ray is from the left. Most of the books above, whatever I read, 2 or 3, so the direction is always taken as left direction of incident ray, and this direction is always taken as positive. Okay, but there is no fixed direction. It's depend on how the incident ray travel. Incident ray, the direction of incident ray taken as positive. Okay, direction of incident ray taken as positive. So this is the direction. Suppose we put something there, F2, C2, C1, F1, whatever is there. So the all distance measured from O, that is optical center, opposite to the direction of incident ray, taken as negative, and all distance measured from O in the direction of incident ray is taken as positive. But there is a fixed thing. What is that? What is that? What is that? Focal length. Focal length of convex is always taken as positive. Always taken as positive. Always convex lens, focal length is taken as positive. And focal length of concave is always taken as negative. This is very important. This is very important. This is very important. Always, the term always, focal length of convex is always positive, focal length of concave is always negative. And whatever the direction is used to measure object distance or image distance taken as direction of incident ray of light are positive. In this direction is positive. Generally all books I read S. Verma were generally given that left side is taken as positive, but there are no any mandatory side which can be take positive. But most of the books in India use left side is positive. Generally S. Verma have this same thing for other books or NCERT book also. Now I am going to ask a question. What is that? I am going to ask a question. What is that? We all know this is a Cartesian form. So this is taken as origin also. And whatever the direction is measured from origin in this direction is taken as negative. Minus x-axis होती थी, plus x-axis होती थी. Whatever the direction is taken from this direction is always taken as positive. So this is positive. Whatever the direction we use in the upward direction is taken as positive. So we use the direction of object. The direction of object is positive above the principal axis, and the direction of image, suppose there is image form like this, always taken as negative of convex mirror form. Any mirror form image, if the image is in this direction, this is taken as positive above the principal axis, and below the principal axis taken as negative always. So you remember this very well. So I am going to solve a question. Suppose I rub this one. Suppose there is a convex lens whose focal length is suppose there is a convex lens whose focal length is 10 centimeter and an object is at distance of 20 centimeter from optical center O or lens. Then find the position of image. Then find what? Find position of image. So what we use to find? We use this formula. Position of image बोला है. Then we are going to use this formula, lens maker formula. So suppose I make the diagram over there. This is convex lens. This is optical center. This is principal axis. Suppose this is focal. So what? Focal length given is how much? 10 सेंटीमीटर. कैसा लेंस? कॉन्वेक्स लेंस. कॉन्वेक्स लेंस का फोकल लेंथ ऑलवेज कैसा लेते हैं? डायरेक्शन इसमें नहीं देखते हैं. क्या देखते हैं? ऑलवेज लेते हैं, हमेशा पॉजिटिव. तो फोकल लेंथ इज इक्वल टू प्लस 10 सेंटीमीटर. क्यों लिया प्लस? कॉन्वेक्स है इसीलिए. दूसरा ऑब्जेक्ट कितना दिया हुआ है? 20 सेंटीमीटर. और हम लोग नापते कहां से हैं? फ्रॉम ऑप्टिकल सेंटर. ऑब्जेक्ट इज 20 सेंटीमीटर अवे. अगर ये फोकल लेंथ है 10 सेंटीमीटर, जो कि प्लस में लिए, क्यों? क्योंकि कॉन्वेक्स लेंस है. तो 20 सेंटीमीटर इधर कुछ होगा, 20 सेंटीमीटर इन दिस डायरेक्शन. सो दिस इज टेकन एज, बिकॉज इंसिडेंट रे ऑफ लाइट गोइंग लाइक दिस, ऑब्जेक्ट इज देयर 10-20 सेंटीमीटर here. So incident ray going like this, then this is direction is positive, but we measure from O, so this direction is negative. So what is object distance? Object distance is U, and U is taken as negative what? 20 centimeter. Focal, we have focal length, we have U, then we can easily calculate V, image distance. So use this formula. I rub this portion. So when I putting this in this formula, these values, we get finally the answer. Apply this formula. So what? 1 upon focal length 10 सेंटीमीटर. लिख भी सकता हूं, नहीं लिख सकता हूं, उसको हटाता हूं. इज इक्वल टू 1 upon V, दिस इज कैलकुलेट, माइनस 1 upon U. U is what? Negative 20 centimeter. Negative 20 centimeter. So negative and negative into positive. So positive, and this positive come this side, then 1 upon 10 minus 1 upon 20 is equal to 1 upon V. So what is the LCM of these two? If we came common, take 1 upon 10, then what? 1 upon 1 minus 1 upon 2. 2 minus 1 upon 2 into 1 upon 10 is equal to 1 upon V. So what that? 1 upon 20 is equal to 1 upon V. If we inverse this, what we get? 20 is equal to V. This is what? In positive. So image is formed in positive direction. So V is equal to plus 20 centimeter. 20 centimeter पे image बना. So what we see that there? That means we see that object is at center of curvature, then image form at center of curvature of same size. So size वगैरह के बारे में बात नहीं करना था, केवल इमेज के बारे में बात करना था. So what? This is your answer, which is similar to object is at center of curvature. Okay, thank you.